Hello. This time we're going to continue our pursuit of um, l- learning and solving ordinary differential equations. And this time we're going to solve an equation that is very similar to one we've already solved a couple of videos back. Um, Before we solved an equation of the form d squared x by dt squared plus k dx by dt plus k x equal to 2k. So we had an equation like that, and we solved this by substituting x equals u plus 2. Now, the equation that I want to deal with today is the equation of the form d squared x by dt squared plus k dx by dt plus kx equals minus 2k. Okay, right, so let's find an equation to solve. So how about if we attempt to solve d squared x by dt squared minus 4 dx by dt plus 4x equal to minus 8, right? So what we're going to do is, excuse me, we're going to substitute x equals u minus 2 and see if this works. So we want to know, does this work? Okay, well, we've got x equals u minus 2. We'll write this down again. X equals u minus 2. So therefore x dot equals u dot and x double dot equals u double dot. So we can write this equation. I'm going to call this equation dagger again. So this is equation dagger. We'll just go back down. Oops, my goodness me, what's happening there? I think we'll have to. So let's see. So equation dagger, that just means dagger instead of equation 1. And let's hope that this scrolls down okay this time. Yeah, so we've got, I'll just rewrite the equation out again. So we've got d squared x by dt squared minus 4 dx by dt plus 4x equals minus 8. So substituting this in for this, u dot in for dx by dt, and u minus 2 in to x, we obtain, I will get rid of those little marks there, then it's not too crowded. So we've got d squared x by, oh, just a moment, I've made a mistake. D squared u by dt squared minus 4 du by dt plus 4 times u minus 2, and that's equal to minus 8. Okay, now bear in mind that I'm sort of using mixed notation here, and it's just because it saves space. So for example, if I can just click on my red pen here, this u double dot up here actually means d squared u by dt squared, and of course u dot means du by dt. That's all that I'm doing. It just saves space, simple as that. So let's just get rid of that, and then it's not too crowded. So we want to simplify this equation that we've got. So what we get is d squared u by dt squared minus 4du by dt plus 4u minus 8 equals minus 8. And straight away we can see that it looks like our substitution does work, because the minus 8 cancels. It's equivalent to adding 8 to both sides to get rid of the 8's. So what we now have is d squared u by dt squared minus 4 du by dt plus 4u equals 0. Now this is really easy to solve, or at least you should be finding it easy to solve, because if you use the substitution for the auxiliary quadratic equation, put u equals a e to the mt, such that u dot is equal to a me to the mt, and u double dot is equal to a squared e to the mt, then if you substitute this in for d squared u by dt squared, this in for du by dt, and this in for u, and then cancel all the a's and the exponentials, the auxiliary quadratic equation is m squared minus 4m plus 4 equal to 0. Now, can we factorize that? We might be able to. Well, I'm hoping we can. So let's just draw two brackets. If we can't factorize it like this, we'll just use a quadratic forming. So we've got m and m. Now we need two values which, when multiplied together, give minus 4. That is a product of plus 4, sorry. So two numbers which, when multiplied together, give plus 4, and which, when added together, give minus 4 here, minus 4. So if we choose these two values to be minus 2 and minus 2, then we'll just multiply them out again to see if we get this auxiliary quadratic equation here, just to check that we're right. So we've got m squared, so we do m, let me just, so we do m times m, which is m squared, m times minus 2, which is minus 2m, minus 2m there, minus 2 times m is minus 2m, and minus 2 times minus 2 is plus 4. And that should be equal to 0. So we've got m squared minus 4m plus 4 equals 0. So we can surmise that m minus 2 equals 0, implying that m equals 2. Now that appears to be one root, but it's actually a repeated root. Okie doke. So there are two values for m, but they're one and the same. Now the solution to our differential equation in U, which I'll denote as dagger dagger, is of the form, we'll actually write it out. So U is equal to what have we got? We've got a e to the mt plus b t e to the mt. Well, we know that m is 2, so we've got u equals a e to the 2t plus b t e to the 2t. And we can simplify that a little bit. Yes, so we'll do u equals e to the 2t times a plus b t. And we already know what u is, because we find it from this. Just a moment. We find it from this. So we've got x equals u plus 2 right, we know that x equals u, did I say minus 2? I think it is. So therefore u equals x plus 2. Henceforth, we have, and I'll write this in red, we have x, if we substitute x plus 2 in for u, we have x plus 2 equals e to the 2t times a plus bt, and from that we can surmise, therefore, a general solution of d squared x by dt squared minus 4 dx by dt plus 4x equals minus 8 is, if we just move the 2's to the other side, or alternatively, if you subtract 2 from both sides, you get x equals e to the 2t. Excuse me, press the button on my pen again. So e to the 2t, a plus bt, I don't think it's -2, isn't it? Yeah, so you subtract 2 from both sides of that equation in red just there, and that is the general solution. So again, we seem to be making some progress, I hope, and I hope that has helped you and that you will come back and watch more of my future or even past videos. So until the next time, I bid you farewell for now and see you soon. Okay, bye.